right, so today's objective is to connect repeated addition to multiplying a fraction by a whole number. So today we're going to be multiplying a fraction by a whole number, and we're going to be looking two different ways to do that. Let's start off with a quick review of what we did Monday, right? So Monday we saw that 1/3 of 6, we could draw an array for it, split it up into 3 groups, and we saw that 1/3 of 6 equals 12. Today, we're replacing that of with times because 1/3 times 6 would also equal 12. So we're just connecting what we learned Monday to today. So this next problem is 2/3 times 6 or 2/3 of 6, right? So in order to do that, we would need to do 6 times 2/3. So kind of looking at the repeated addition, well, if I have 2 of 6's, right? I have my 6/3 plus 6/3 equals 6 plus 6 over 3. Or that would also just be the same as multiplying 2 times 6. So kind of multiplying the 6 times the 2. Still keeping the same denominator. So 2 times 6 is 3 equals 12/3. Right? So we're noticing that when you multiply this whole number times a fraction, it connects to repeated addition here. But we also know that repeated addition has a shortcut, and that shortcut is multiplication, right? And so today we're going to be applying that with that. Let's continue this problem. So 6 times 2/3. There's kind of two ways of thinking when solving problems like these, okay? So over here, here's our little friend. He has two thought ideas. Here on the left, 2/3 times 6, 6 times 2/3, those are the same, right? So we know that that means 2 times 6 over 3, or 6 times 2 over 3. Again, we can switch those up. 12 over 3, we learned last week that 12/3 is the same as 12 divided by 3, which would give us 4, right? Here's like another way. This is a more like challenging way of trying to think of it. So here's same thing, 6 times 2 over 3. But if you look here, there was a 3 and a 6 there. You can sort of reduce while you're going. So I know that 3 and 6 can both be divided by 3. So I could say, well, 3 divided by 3 is 1. And so then I reduce that. But then I also need to divide something in the numerator by 3, right? To keep them equivalent. 6 divided by 3 would equal 2. So now what you're left with is 2 times 2 over 1, which would then just be 4 over 1, which equals 4. So two ways to think of it. Right now, I really want us to focus over here on the left-hand side. You're going to multiply it. It's going to be a fraction, and then your final step will be dividing. All right, problem 2. 3/5 times 10, right? Or 3/5 of 10. We can also flip it over, 10 times 3/5. Same thing. Again, focusing on two different ways of solving this problem. So here we could do 10 times 3 in the numerator over 5 in the denominator. 10 times 3 equals 30. 30 over 5. That would be the same thing as 30 divided by 5. So we would get 6, right? And then here's that challenging way that we also looked at in the last problem. So 10 times 3 over 5, right? So far, they both look fine, or they both look the same. But you kind of want to reduce as you go, if you can. So if I look here, I can tell that 5 can go into 5 and 10. So 5 divided by 5 equals 1. 10 divided by 5 equals 2. Now, I just have to multiply the 2 times 3. That would equal 6 over 1. And 6 over 1 would just be 6. Let's look at problem 3. All right, so here we have 24 times 5/8. So here we can kind of draw out 24 times 5 over 8. If I multiply 24 times 5, I'm going to get 120. So now I have 120 over 8. Remember, we saw last week how a fraction can be like division. So now we need to rewrite it. 120 is the dividend, and we're dividing it by 8. So if I go ahead and do long division, 8 goes into 12 one time. 1 times 8, 8. I subtract. Now is the 4. Bring down the 0. 8 can go into 40 5 times. 8 times 5, 40. 40 minus 40, 0. There's no remainder. So 24 times 5/8 equals 15. Let's look at it at the second way of solving it. So if I wrote 24 times 5 over 8, I could tell that I could divide the 8 and the 24 by 8. 8 divided by 8 would give me 1. 24 divided by 8 would equal 3. So then over here, I am doing 3 times 5, which would equal 15, and then just this 1 here as the denominator. And 15 over 1 equals 15. Both ways gave us the same answer. It's up to you which one you feel more comfortable doing. Our final problem of the day, 7/6 times 24. And this one, you'll notice, is a little different because the fraction we're multiplying it by is greater than 1. So important thing to note here, if you're multiplying times something that's greater than 1, your answer is going to be greater than this starting fraction. So like if you look at the last problem, we did 24 times 5/8. 5/8 is less than 1. So we saw that our answer got smaller. And this one, I can already tell that our answer is going to be bigger because this fraction is greater than 1. Same thing as before though, in the numerator, I'm doing 7 times 24. And then the 6 just remains at the bottom. 7 times 24, if you do that, it's 168. And 168 divided by 6, now I need to do long division. So you can see here 6 goes into 16 2 times, 2 times 6, 12, subtracted, brought the 4, brought the 8 down, 6 goes into 48 8 times, 6 times 8, 48, subtract 0. There's no remainder here. The answer to this problem is 28. Notice 28, a little bit bigger than 24, but it is bigger because we multiplied it times 7/6. Now let's look at it the challenging way, right? So if I do 7 times 24 over 6, I can divide 6 and 24 by 6. 6 divided by 6 is 1. 24 divided by 6 equals 4. So then over here, I multiply 7 times 4 equals 28. The 1 just stays at the bottom. Again, our answer is still 28. Nice. And now you get to try it on your own. So your exit ticket for today is 2/3 times 15. So try to solve it both ways that we just learned. But if you only feel comfortable doing one way, then I would recommend doing that. But try both ways, see what you think of it, and save that answer for later.
Thanks for watching.